Right, I'm going to go over question 4 on page 113, exercise 5C, which I sort of half set last lesson, but I don't think many of you got round to doing it, but it's not a bad one to go over actually. So do look it up in the books, but we've got sphere A, sphere B. Sphere A has mass m, B mass 2m. B is stationary before impact. Velocity of A makes an angle theta with a line of centres. And the direction of motion of A is turned through 90 degrees by the impact. E is E, and we're trying to get to, I'll just jot it down here, tan squared theta equals 2E minus 1 over 3. So after the collision, we know that B will be moving along the line of centres. So B is going to be moving in this direction. With A, we know that perpendicular to the line of centres remains unchanged. I'm going to call this one here U. And then we know this motion is deflected through 90 degrees. So rather than going this way, it's going to be going this way. So you can sort of pull it past to think about that deflection. So motion is going to be going this way. Line of centres, probably be good just to pop that on. So here. And so that this angle in here will be 90 minus theta. So it was coming in at theta. I haven't drawn my diagram amazingly well to match that one, but deflected through 90 degrees. So that's the 90 degrees, that's theta, which makes that bit there 90 minus theta. And that's going to prove to be really useful in the question. So I'm going to call this one V and this one here W. But yeah, use your favourite letters. And then, I don't know if I meant to have that off, no, it's too late. So then just use everything that you've got. So perpendicular to line of centres. We know that U sine alpha, theta, is equal to V sine of 90 minus theta. We were looking at this in an example the other day, and sine of 90 minus theta is the same as cos theta. So I would assume that we're going to be using that for this question. So we've got an equation. We've got the other thing to think about is if you can generate we've got 4 unknowns, but we're trying to find theta in terms of E. I'm not including E here, but we've got U, V and W. So I'm really looking to get 3 equations out of this. Parallel to line of centres, we can work with momentum. So I'm going to take this way as positive. If a lot of things are going that way, you could take that way as being positive, but that's not the case here. So momentum, mu cos theta is the momentum before. Momentum afterwards is going to be 2m w minus mv cos of 90 minus theta. The masses are all going to cancel off, which makes life a bit easier. And then cos of 90 minus theta is sine theta. So u cos theta, that was meant to be a W. So that was from there. Did I say W might V? 2mw. So that should be 2w minus V sine theta. So we have another equation. And then we can also work with restitution. And so E times the approach speed, which is u cos theta, is going to equal the separation speed, which is going to be this one plus this one. So I've got v cos of 90 minus theta, which is v sine theta plus w. And that gives me my third equation. I want to really get rid of these w's to start with, because this one's linking u and v, so we can work with this, but these w's are getting in the way. So I'm actually going to times this one through by 2. And call that equation 3. And then I can just do 3 minus 2. So I'm doing 2 EU cos theta minus u cos theta. And that's going to equal, so these are going to cancel off, 2v sine theta minus v minus v sine theta. So that's 3v sine theta. And then we're trying to get an equation in terms of tans, so it makes sense to divide through by cos theta. So 2EU minus u is equal to 3v tan theta. But we know from up here that from 1 that u tan theta is equal to v. So v is equal to u tan theta. So that's from there. So we can substitute in. I think I've just got enough room for this, hopefully. So I've now got 3u tan squared theta. And then you can divide through by u. So they're all going to cancel off. That's going to be 1. And so tan squared theta is going to equal 2e minus 1 over 3 as required. So there's a lot of letters in there, but the concept's no more difficult to what you were doing yesterday. So I'll set some questions similar to that. Which one is it? Question 16 is really good to do. That's quite similar to this one, but there's a few more before that for you to look at too.